Hi everyone, welcome back to another video. This is Codeforces Round 929 Div.3 and we're gonna solve the fourth problem, that is turtle tenacity and continual mods. So let's see what the problem states. So we'll be given an array a1, a2 up till an and we have to determine whether it's possible to rearrange the existing elements a1, a2 up till an to b1, b2 up till bn such that if you continuously take the modulus from left to right, you get a remainder of not 0 or not. So let's take an example and try to understand it. If you have a number sequence like 1, 2, 3, 4, 5, 6, the first problem that they give, you can rearrange the elements. For now, let's take whatever be the input element they give. So we'll just take the modulus here. So you take the modulus just means remainder, right? So what will be the remainder of 1 mod 2? So 1 mod 2 will be 1. 1 mod 3 will be 1, 1 mod 4 will be 1, 1 mod 5 will be 1, 1 mod 6 will be 1. So this one is not equal to 0 as they told. So we can say that there exists a permutation such that this answer is there. So we are simply printing yes. Can we try some other permutation? Maybe we can give like 6, 5, 4, 2, 1, 3. Let's see what happens. 6 mod 5 is, so 6 mod 5 will be 1, 1 mod 4 is 1, 1 mod 2 is 1, 1 mod 1 is 0 and 0 mod 3 is 0. So 0 is equal to 0. So this is not possible. This is not a valid permutation. They are just asking, is there existing at least one permutation such that the answer is non-zero or not? So we have a non-zero sequence. So that's it. It's yes. Now let's try for other one. And similarly, if all the numbers are 3, obviously it will be 0, right? And 2 to 3. If we take 2 to 3, what happens? 2 mod 2 is 0. 0 mod 3 is 0. So the answer is no, but they told us yes. What is the other combination? What they did is, they did 3, 2, 2. 3 mod 2 is 1 and 1 mod 2 is 1. So there exists a sequence like 2 to 3 and 1, 1, 2, 3, 7, 0, and these all things you can find out. We'll try for 3, 6, 9, 3 maybe. So 3, 6, 9, 3, what happens? They are telling that you can produce a non-zero. So let's see. 3 mod 6 is 3, 3 mod 9 is 3, 3 mod 3 is 3. No means it is 0, right? It is 0. So 3 mod 3 is equal to 0. So they are telling that whatever permutation you take, you cannot get the answer. The remainder will always be 0. So to clarify this yes no, we'll just write it down somewhere. So two things will come. One is yes and the other one is no. When can you say it is yes? You can say yes when you are able to produce a non-zero. When can you say no? When you are, whatever be the permutation you take, it is always 0. This means at least one permutation exists. 0 means all permutation, if you take from left to right, it is 0 only. So this is the end goal that we need to achieve. So two things that we can do here. Either write all the conditions for yes and then in the else condition simply put no. Or else what you can do, you can put all the conditions for no and then you can simply put yes. So whatever be the simplest format, we'll try to take it. Now, what is the first thing that we observed? 1, 2, 3, 4, 5, 6. It is coming as 1 not equal to 0. It is obviously yes, right? We are able to get it. What is the specialty of this is, if you observe closely, when there is a smallest number on the left and all the numbers are so bigger, the modulus will be the remainder will be the smallest, right? So if you have 1 and if you have 100 and 1000, what happens? 1 mod 100, it's always 1, the smallest number only, and 1000 is so big it cannot find a remainder. It will be 1 only. Even if it's 2, even if it's 3, it will be non-zero only. So that's why they kept these numbers. So if you sort it and the first number is not equal to the second number, then definitely we can say that there exists a non-zero and it is yes. Now this is one condition, we got it, but there can be many other conditions, right? So from this we understood this one, but there can be many conditions. So if you see all the numbers are equal means 3, 3, 3, 3, 3, they gave us no. That means every time it will be 0 only, the remainder. 1, 1, 2, let's try for 1, 1, 2. What did they give? 1, 2, 3, 1, 2, 3. They gave us no. Every time it will be 0 only. Let's see for 2 to 3. Okay, let's take for 2 to 3. What happens? 1, 2, 3, 2, 3. They gave us yes. So if there are 2, if we sort it, and if two small numbers come, it can be no or it can be yes as per the test case only. Now, what is the speciality that is happening here? Here also you can see 3693. So if you sort it, what happens? Why am I sorting it? I'm just sorting it to say that if there is a smallest number and if there is a biggest number overall, the smallest number will be the remainder, whatever be the case from left to right. Now here also same thing, 3369, the answer is no. There is no permutation such that the remainder will be 1. What is the specialty of this? If we are able to figure out, then we are almost close to answer, because we found for single element, now we have to find for duplicate elements. Equal, we can't do anything, it's obvious. 1 1 2, 1 mod 1 is there, 1 mod 2 is there, but here how did we get yeses? What did we do here? Only 3 numbers are here, we can do any permutation, right? So what did I do? I converted it to 3 2 2. I just by trial and error. Okay, 3 mod 2 is 1, and what is the answer? This one will go here, right? 1 mod 2, again it's 1. So what did I do? This 3 has been divided by 2 to get a remainder of 1. Then using that one, I got this as 2. Can I do the same here? 9 mod 3, it will become 0. 3 mod 3, it will also become 0. I cannot reduce any number. I cannot produce a non-zero number. So now again, let's understand something. When can a modulus produce 0? That means it should be a perfect divisor, factor, or whatever you call, right? So 9 mod 3 perfectly divides. That's why we are unable to get it. But 3 mod 2 does not divide. So we are able to get a number that is smaller than that. So how can I make you understand further is, see, 1 1 2 is here. Whatever you do, you will get 0 only, because 2 mod 1 is always 0, right? 2 can divide 2. 2 can divide 1. 1 also can divide 1. Even if you take 1 mod 2, the remainder will be 1 only. But again, 1 more 1 is there here, right? So 1 mod 1 will be 0. 3369. Whatever number you take, 9 mod 3, it becomes 0. 6 mod 3, it is also 0. But you take the opposite. Suppose it's like 3 here. 3 mod 6 is 3. 3 mod 9 is 3. But again, this will kill the 3. 3 mod 3 is 0. The only specialty is we have to see whether the first element, if it is having a duplicate. If it is not having a duplicate, then definitely the answer is yes only. If it is having a duplicate, we have to see, are there any other number? If it divides the first smallest number, then is it able to produce a non-zero number or not? So suppose if it is x, y and z, this is x, x and z. If z mod x is not equal to 0, then definitely I can say that z mod x is much less than or equal to x, right? Is less than x only. So suppose like lot of numbers are there, x, 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 z, a something. If z mod x is not equal to 0, let's say that z mod x equal to c will be much smaller, right? So if it is much smaller, it can, as per our first rule, it will be the non-zero number only. Then I'll use this one to create c, and using c, I just simply mod. C mod x is c, c mod x is c, c mod a, c mod a, c mod a. So the answer will be c only. So what are the things that we did? So we'll just sort it. If the first two numbers are different, that means what? This will be smaller, and all the numbers are bigger, means then the answer will definitely be yes. What is yes means there exists at least one permutation where it is non-zero. Now, if it is not the smallest number is having multiple duplicates, there are two conditions that can arise. One condition is whether any other number can perfectly divide or not. If all the other numbers on the right side perfectly divides, there exists no permutation. If any one number that perfectly divides, I will use that number to reduce it to some other number smaller than the smallest number. Then using the first rule, we will be able to say that no, there exists no, the remainder will be non-zero. So that's what I did here. So v of 0 is not equal to v of 1 means after sorting this condition, 1 is not equal to 2. So you're simply printing yes. If there are duplicates that are coming on the left side, I just want to see from the right, are there anything that perfectly divides? If it does not perfectly divide, then I can definitely say that there exists a smaller number. Using that number, I'll be able to compute for others. So I'll just put f equal to 1 and break. Where is it? It is 322, right? So it is 2, 2, 3. So what do I do here? 2 mod 2 is 0. So 3 mod 2, it is non-zero, so I break and I print yes here. In all other cases, if it is 1, 1, 2 or something, it will be no. So let me just confirm 1, 1, 2 is no only. So that's it. So why, again I'm telling, like, why did we choose that? If some number divides some smaller number, it will produce some other smaller number which will directly be much less and will never form 0. So that's it, guys. If you have any doubts, please let me know in the comments. We'll be glad to help. Thank you so much. See you in the next video.